So this little LM386 IC chip is actually one of the coolest ICs ever made, in my opinion. So this is going to be the heart and soul of my next amplifier project. There are an overabundance of videos on this amplifier chip, but for this build, I'm going to do something that I haven't seen anybody do yet, not even on the internet. And if you've clicked on this video on aspirations of a kind of a beginner's circuit of how to do it, I'd say go ahead and stick around, because the first test I'm going to do with this, I'm actually going to use a bare bones minimal component circuit that should be easy for anybody who is a beginner level to tag along with. The amplifier build is going to actually require 4 different LM386s. We'll get into that in more detail later, but for now let's make one of these relevant again. Alright, so the LM386 chip. This is an awesome little audio amplifier. It's not going to blow your speakers out or anything, or you probably won't even get in trouble for playing that too loud if you're, of the age where you would still get in trouble for listening to music. I don't know. We're already going down a rabbit hole. But I have my positive and negative leads coming in. So this whole red one is going to be our positive for our power, and then the blue one next to it is going to be our negative. I've already got a couple of little leads already plugged into there. So now, like I said, this is going to be a bare bones minimal circuit. And now what I'm going to be doing here is I'm actually going to be testing this 8 ohm speaker that I have, and I'm going to be testing a way that I can actually lower the frequency or actually make a crossover point, because this one is going to designate all of the low frequencies to a speaker, and then I'm going to do another one for the same channel that's going to designate all the high frequencies to another speaker. So for right now, we're going to go ahead and make a very, very plain Jane circuit. It's not going to sound the greatest, but that's because there's going to be a lot of components missing that I'm going to actually put in to make it sound a lot better. So the first thing we can do is kind of go over the pin layout real quick. And the pins go 1, 2, 3, 4, and then jump over to 5, 6, 7, 8 in that order. So for the pins, 1 is 45, and then 44 is 4, and then you come up here, 15 would actually be 8, and then 16, 17, 18 will actually be 5, and then 6, 7, 8. So we got 18 through 15, and then 45 through, 42. I just said that wrong the other way. So all right, for this very simple circuit, all we're going to need is, I'm going to do a 220 microfarad capacitor, and this is just going to be for the power supply, but I'm going to do it really close to the chip. So number 5 is our positive in, and then 4 is our ground, but I'm also going to designate 41 to ground too. But what I'm going to do is take real close to the chip and then jump this between our positive on 6 and then our ground on 4. Next, I'm going to go ahead and grab one of these little tiny jumpers, and very gingerly I'm going to connect, like I said, 42 with 41, but I kind of want to do it like right here. Well, no, actually, let's move down to about right here. Okay. So now we have jumped 42 with 41. So 42 and 41 are all going to be ground plane. Now this is a 10K resistor, and what we're going to do is we're going to bridge number 3, which is our input, back to ground. So we're going to go 43 to 42. And you kind of want to try to do it close to the IC as possible. I have to open these up a little bit. Okay. Very gingerly. Okay, that'll do, I believe. All right, now we're going to go ahead and take our power, just coming from our red one, And we're going to put it on pin 6. So now our power is hooked up. Now we're going to take this other one. I apologize for using the same color leads. I'm going to take this as our power ground, and we're going to put that right in our ground plane. And then what I've did is I've taken this 3.5 millimeter jack and I actually connected some breadboard leads onto it. So the green one is one channel, the red one is another channel, and the brown one is ground. I know I should have put green as ground. So since I'm only going to be using one channel, what I'm going to do is take, now remember, the positive lead goes to number 3 on the pin. So that is your positive input. I will also take the brown, does not go to your ground plane, although it could. We'll get into that more later as I get further into these different circuits that I'm going to be trying to make this work. But for now, we're just going to put this to number 2, which is your negative input. And just so this isn't like all flopping around, I'm going to take this green one and we're just going to stick it down there. So there. I just realized that's out of view for you. So, okay. I've already got leads hooked up to a speaker. I will show you the speaker here in a second. It's a very nice 8-ohm speaker. It's actually from 1958. It's pretty cool. Check out my shorts. I did a short on it, but check that out. You can actually see the coil moving up and down. I like these old speakers. They're so cool. All right, so speakers are hooked up. Hopefully, almost. And who's coming on the bench? Of course. I can start to see why people don't like cats. All right. So now what I'm going to do is I'm going to go ahead and take one from pin 5, which is our output for our speaker, and I'm going to bring it to another trace over here. Because from this point, if you want to make this circuit, and this is your first time kind of checking the circuit out, just go ahead and start with this, maybe research, and then you'll find ways to improve upon it. But this is the simplest way. You would just stick your positive lead to 5, and then from here you would just stick your negative lead from your speaker over to your ground plane over there, and then you would be good. But for here, I want to make a positive there. And I guess we'll go with the yellow theme. But I want to take from my ground plane, which is pin 4, back over to another pin over by our negative lead for our speaker. And this is going to allow me to put components in there that are actually going to allow me to manipulate the sound and stuff like that. Excuse me. You're not ready if you are just planning on making this, just a small circuit, an easy circuit. You will need one more thing. Now this is a 1500 microfarad capacitor. 1000 is recommended for bass, and then you want to bring it down from there. It will kind of decrease the bass. For this, I believe it's a DC blocking capacitor. But what you want to do is the positive end, and that's always the longer of the leads. The longer one is the anode, the shorter is the cathode. But you can see it says the negative there. The negative goes towards the speaker, and then the positive is going to go towards whatever the amp is, or coming from the amp. So what I'm going to do is I'm going to stick that right over there, and now you have a full circuit. But all right, I'm going to go grab another phone so we can check out some music and hear how it sounds just like this. Okay, we have everything set up as the circuit stands. I'm using my benchtop power supply, and it's kind of noisy, and there's going to be a lot of noise too because what I'm using makes noise, my phone makes noise. A little tip for anybody recording on your phone with an external microphone or even anything like that, put your phone in airplane mode if you plan on doing that. You'll skip a lot of unwanted noise. So we're on down there. 10 volts is fine. They run off a 9 usually. So I didn't hear anything when I turned it on. Oh, I didn't turn it on. Output. There's that noise. Wow, is that noisy. It might be because this capacitor is so far away. Oh, wow. Something was not making contact. I don't believe it was getting to ground. Still sounds horrible. Now, like I said, as everything sets, this does not sound very good at all, but I'm just going to do this for the purpose of demonstration. Try not to worry too much about the clicking and all the other noises. Stick along with us and go ahead and watch the rest of these. I will show you how to make the LM386 sound very, very good and a lot better than what this is actually going to sound like. So I've been using a Maser laser, and I mean, doesn't sound too bad, other than, yeah, those pops and stuff. I've been having connection issues. But what I wanted to do was show you how I plan on cutting down the low or the higher frequencies by just adding a capacitor. I don't know if you can hear that, but let me kind of start the song back a little bit. Definitely cuts it down. Now if we take another 100, now if I take another 100 microfarad capacitor, you can tell the high frequencies are highly cut off because I have 147 microfarads of capacitance. Definite connection issues. So now what I'm going to go ahead and do is I'm going to take one capacitor out. You can hear how the treble kicked up. Now we're going to take this last one out. And you can see the treble really kicked. It got louder, but it was cutting out the higher frequencies. Now another thing I can try is I can try this little coil and run it in series between my positive. Let's see what that does. Still getting the popping, but this is with a 3 microhenry inductor. Let me go back to where there's more treble. Definitely cut it down. So I don't know. I don't know if I'm going to use an inductor or if I'm going to use a capacitor. So let's pull that inductor out. And it's just regular. So there you go. I hope that kind of demonstrated how either having a couple of capacitors in parallel with your speaker leads can actually drop off some of those higher frequencies, and also a coil. So I think for the next step, I'm going to go ahead and do a little bit more research and test them a little bit more. And in the next video, we're going to make a proper circuit for this, and then we're going to go ahead and test for low and high as well. All right, so there it is. If you guys have any comments, questions, or maybe even a little bit of help, go ahead and put down in the comments. I'll go over one more time what I'm doing. I'm calling it a quad amp, and it's going to be stereo with LM386s. Two of the LM386s are going to be dedicated on low frequencies, and then two are going to be dedicated on high frequencies. I'm kind of not wanting to do the input signal manipulation, more of the output, but it might be easier to just manipulate the frequency going into the input, and then I wouldn't have to worry about the passive crossover kind of network I'm trying to do here. I think I might go with the coil as far as knocking off the high frequencies and kind of keeping the low frequencies, but I'm not sure yet. Stick around and definitely check out how this progresses, and I think it's going to be pretty cool. With that, I thank you, and we hope to see you on the next one.